all around us, our world is speaking. It's a language we've just never been able to hear. Today, we're going to tune in to this hidden dimension of data, a signal that's flowing from the very buildings we live and work in, and we're finally going to find out what they've been trying to tell us all along. I mean, think about it. What if the bridges you drive over, the office you work in, the place you call home, what if they're all constantly communicating, sending out vital information about their health, their efficiency, and maybe even their future? For decades, this language, a language of stress on a steel beam, of tiny temperature shifts in an AC unit, of wasted energy bleeding out into the night, it's all just been a silent broadcast. We simply didn't have the right equipment to listen. Well, until now. So here's our game plan. We'll start by decoding our building's hidden language. Then we'll look at the massive cost of, well, ignoring it. We'll meet the incredible technology that's finally letting us listen in and see how this conversation is already changing our world, from a single room to an entire city.
All right, so to really get this hidden language, we have to kind of shift how we see our surroundings. A building isn't just a static object of concrete and steel. It's a complex, dynamic system, constantly generating these massive streams of data about its own condition.
And this brings us to this big idea called Maintenance 4.0. Really, it's a fundamental shift in how we interact with our environment. We're moving away from the old way, fixing things after they break, and toward a smarter, more proactive way of taking care of them, all driven by data. But why is this shift so important? Why now? Well, because for years, not listening to our buildings has come at an enormous cost. A cost you can measure in dollars, sure, but also in wasted resources, unexpected disasters, and just lost potential. Get a load of this statistic. It's pretty staggering. Research shows that traditional reactive maintenance, just waiting for things to go wrong, can eat up to 65% of a facility's entire annual budget. That is a colossal amount of money spent not on making things better, but just on putting out fires. And this really gets to the heart of it. The old model is reactive. You wait for a system to fail, which leads to unplanned downtime, angry customers, and super expensive emergency repairs. The new model is predictive. You use data to see failures coming before they ever happen. This allows for planned, optimized fixes. It's the difference between getting caught in a hurricane and seeing it on the weather radar when it's still hundreds of miles away. So the big question is, how do we make that leap? How do we go from reacting to predicting? Well, the key is this truly revolutionary technology that basically acts as our universal translator for the language of buildings, the digital twin. Now, a digital twin is so much more than just a 3D model you look at on a screen. Think of it as a living, breathing, virtual replica of a real-world building. It's connected to the physical structure through a whole network of sensors, constantly feeding it data so it mirrors the exact condition of its physical counterpart, right now in real time. And this technology didn't just appear out of nowhere. It's been evolving. It started with a basic digital model, a static blueprint. Then came the true digital twin, which had that critical two-way flow of real-time data. But now, we're really entering the era of the intelligent digital twin. This is where things get crazy. It uses artificial intelligence to not just mirror what's happening now, but to simulate possible futures, predict failures, and even suggest the best way to fix them. Okay, so that's the concept, and it's a powerful one. But how does it actually work? What's the fuel that runs this intelligent, virtual copy of a building? Well, the lifeblood of any digital twin is data, and it pretty much comes in three main flavors. First, you've got operation data. This is the live pulse of the building coming from sensors. Then there's attribute data. Think of this as the building's DNA, stuff like its dimensions and what it's made of. And finally, you have evaluation data, which is like its medical history, made up of old maintenance records and even feedback from the people who use the building. And all this data flows through a 4-stage framework. It all starts with sensing and collection. Then that raw data gets processed and integrated. It's cleaned up and put into a single unified stream. Step 3 is the intelligent analysis, where AI algorithms hunt for patterns that might predict a problem down the road. And finally, virtualization. This is where all those complex insights are made simple, put on a dashboard, or even overlaid onto the real world with augmented reality, so a technician can see exactly what needs to be done. This all might sound a little bit like science fiction, but I promise you, it's happening right now, all over the planet. This isn't just a theory, it's a real and rapidly growing global practice. I mean, just look at the research. You can see a clear global trend here.
Italy and the UK are really leading the charge in developing this tech, with the United States right behind them. This isn't some niche experiment. It's a full-on global race to build smarter, more responsive infrastructure.
Let's look at some actual examples. In Morocco, the massive Mohammed VI bridge uses a digital twin to keep an eye on its structural health in real time. The system can spot stress or material fatigue way before it would ever become a problem a human could see, keeping a vital piece of infrastructure totally safe. And it's not just for these huge structures. At universities in South Korea and Norway, digital twins are monitoring and predicting what the HVAC systems need to do. And the goal isn't just about saving a little energy, it's about actively making the learning environment more comfortable and healthy for the students and staff inside. And the scale can get even bigger. In southern Italy, a digital twin is being used to manage an entire transport network. It helps figure out which areas are most vulnerable and allows authorities to plan maintenance across a whole system of roads and bridges, putting resources exactly where they're needed most. So where does all of this lead? Well, it's leading to something much bigger than just better maintenance. We are fundamentally changing our relationship with the world we've built, turning it from a passive backdrop into an active, intelligent partner in our lives.
The takeaways here are pretty clear. We're making that huge shift from reacting to predicting. Our buildings aren't silent anymore. They're these vast, untapped sources of valuable data. And the digital twin is the key that brings all of it together. The data, the AI, the visualization, to create a world that's safer, more efficient, and way more sustainable.
And that brings us right back to where we started. That secret language, we're starting to become fluent. And by learning how to listen to just one building, we're developing the skills to understand the health and performance of an entire city. And that leaves us with one last really fascinating question to think about. We now have the ability to give a single building a kind of digital nervous system. So what happens to our world when we connect all of them? When we create a truly smart, responsive, living city? The possibilities? Well, they're just beginning to unfold.